Recording is rolling. So welcome to Monday. Got a new week. We're finishing up forces. So here's what we got going on. Actually, I'm going to take pretty much all of today and talk about the AP Positive multiple choice questions that you guys finished. It's been up for a while. Now, actually, I have had some students tell me that they could not access it. I've had a handful, probably about 4 or 5 students. And I think what the issue is that sometimes over the weekend, AP's website gets a lot of traffic. There's just a lot of student traffic, and for that reason, sometimes it goes down. Sometimes that happens. So what I'll do after school today is I'll go back and reopen it because it was due this morning. I think I automatically closed. I'll go back, reopen it. So if you haven't had a chance to submit it yet, then you can go to that. Then I can go back and give you points. But I'll go over these questions, especially the most missed ones, and then any commentary that I have about what AP could ask. Tomorrow, I'm going to finally set you guys up with that friction lab. It's going to be a 2-part lab. This is going to take probably at least all day. It might roll over into Wednesday, maybe, because I'm also going to have you guys do an AP style write-up with that. And then I've got the rubric that I prepped for that too. Wednesday, my plan is to do an FRQ with you guys. And then by the end of this week, starting Thursday, centrifugal force lab. Do you guys remember if you're in a car, what can you feel if you're in a car? Can you feel the speed of the car? No. This is one of these things that keeps coming back in this class. Can you feel if somebody, if the driver slams on the gas pedal and starts speeding up? Can you feel that? Yes. You can feel forces and accelerations that comes with those forces. If the driver hits the brake, can you feel that? Yes. Right. So gas pedal and brake. Now that's speed if we're slowing down in a straight line. What I've been telling you guys is that what was the third control that you can also feel in the car? Steering wheel. I said we're eventually going to bring the steering wheel like turning. And oh, look at this centrifugal force. That's coming up this Thursday. This is probably going to take Thursday and Friday, so that's what I'm planning for. And then Friday, you guys remember your Open Notes take-home forces quizzes due. I gave that to you guys back before the weekend, so some of you guys might have finished this already. If you haven't, you can always turn it in early. No, I gave it to you guys back on Friday, and it's due a few days from now. So you guys have a whole week to do this, right? And that includes right now. Right? So you guys got a few more days. And then, also Friday, federal impact forms are due. So, again, if you already got those signed by your parents, then you can always turn that to the grade very early. But, federal impact forms going on this week also. Any questions so far? All right. Before I get rolling on what we're really doing today, I want to go back and talk about Barry Nolan frame a little bit more, because this is something that you guys got a pretty good start on back on Friday, and I wanted to give you guys more time to do it, but this AP Classroom is going to take me all class, and so I'm having trouble to figure out. I don't know exactly when, if you guys are going to have more time to work on this, so let me recap this real fast. You guys were solving an economics question back on Friday, and you're using a physics model. So the idea was you need to build a factory, maybe you're trying to manufacture pencils, and you need wood from this forest and copper from this mine to make these pencils that you're going to ship to this town. And maybe there's different transportation costs associated with each of these. So where would be the optimal location of the factory? Well, if you set this Barry Nolan frame and you represent the transportation costs with lab weights and make those proportional to those costs, then the equilibrium point of the factory will naturally emerge. So I gave you guys an example, and my example numbers are exactly this picture. And then I gave you guys a couple of other setups so you could play around with the lab weights and figure out your own equilibrium positions. And I'll show the back of this page, so I don't know if we'll have time to do this or not, but either way, just get the idea. Suppose that you figure out where the factory should be. So the factory is like right here. And then, okay, so you got like 3 strings emerging from that factory location. So, and you introduce a Cartesian system so that it conveniently aligns with one of those strings. I mean, you can create whatever Cartesian system you want, so probably want to do that. The idea is that the 2 upward forces should balance with this downward force, right? And so wouldn't that be this force times sine of this beta angle, and this force times sine of this alpha angle would be the upwards, up plus up, should balance with this force down. And also the right should balance with the left. So, well, I see the one pulling down has no horizontal component, but this one here, if I do this force times cosine of this alpha, that's how much right. And this force times cosine of this beta, that's how much left. Those should also balance out. So that was the idea. If you know the forces and those two angles, you can calculate right, left should balance out, should be approximately 0 net force horizontal. And the up plus up minus the down should also approximately 0 out. So you're supposed to determine that experimentally, but in case we don't do it, then that's how that was going to end. All right, let's get to today's actual stuff. The reason I threw this starter question up here is because this was one of those problems on AP Classroom that we're going to look at quite a bit. So graph acceleration versus time for the situation of, say I have a, let's say kind of a light block hanging over the edge and then a really heavy block on this incline. And I'll give it an initial push. So it's starting to go clockwise, but that's going to change because that heavy block on the incline is so heavy that it's eventually going to turn around and change direction. Yep. Okay. So can you sketch acceleration versus time for that situation? That's one of your AP questions that we're going to be looking at. What I want to mention while I've got this page up is here's something I've not been in a great habit of doing, but some instructors are, and some textbooks are, depends on the textbook. See that little arrow above the A? But I did not put an arrow above the T. Do you guys know what that short arrow means? Ooh, shows up there too. See that short arrow? What does that mean above the letter? It means it's a what kind of quantity?
Vector quantity.
Vector, yeah, vector quantity. So yes, some textbooks they really do that a lot. So anytime you have a vector quantity, if you put an arrow above it, that's what that represents. But I specifically did not put that over the time because time is considered to be a scalar quantity. Okay. So let me flip my screen over and we're going to look at AP Classroom.